Hello everyone. We are Team Capernaum from Studio Angus. This design studio explores mobility and habitation as intertwined domains, focusing on the environment as meteorological entity. Through the development of mobile and responsive habitats, the studio challenges traditional notions of fixed and rigid boundaries, emphasizing harmonization with natural rhythms. Our research examines underdeveloped and overlooked anthropogenic and natural habitats, identifying opportunities for meaningful contributions aligned with societal needs. Addressing global challenges such as climate-induced migration and conflict, our thesis foregrounds human-centric and responsibility-driven approaches. The studio redefines habitability as an adaptive extension of human body, proposing dynamic infrastructure and collective strategies that emphasize self-sufficiency, adaptability, and resource efficiency.
Yeah, so we start from the climate change. Nowadays, the climate change caused many kinds of extreme weather like drought, flooding, etc. There are lots of regions are influenced by extreme weather, even some places suffering from multiple extreme weather. And at the same time, people are also suffering from the conflicts. Some of the conflicts even lasting until now. We could see some news that the conflicts happen following the extreme weather, which caused the lack of natural resources. Almost 130 million people has been displaced by 2024, which is the largest global humanitarian crisis. So our design aiming to create a better living condition for the refugees. And
so many countries around the world are faced with the problems of refugees. The reason we choose Sudan as our research location is that it has typical extreme weather and conflict crises. It holds the world's most severe refugee situations, but we need to mention that Sudan is just an example nation. We try to design something that is suitable for most refugee situations. So we studied the climate. It faces drought and sometimes flood in rainy seasons, and the geographic situations, and the hotpoint locations. These three elements contribute to the high level of refugee exchange within Sudan, and the exchange refugees between Sudan and the neighbor countries, and that's why there are so many refugee camps in Sudan. These camps are supported by the government or special agencies like UNHCR and can serve as transit points for the movement of refugees and provide some temporary protection.
so during the migrant progress, we found that the refugees are lacking of some basic living materials, even the water, and have no access to have it, or they cannot afford it. According to the research of UNHCR basement, we found that refugees will migrate single or by family unit. And the average amount of people per tent is 2 to 4, but the amount is keep rising because the UNHCR basement is almost overwhelmed. The UNHCR basement will supply some public resources like the education and the healthy facilities, but at the same time, they are lacking of some sanitations, also some special protection for women, for children, also some community construction.
So as a part of our research, we collaborated with two organizations whose efforts are dedicated to scaling decarbonization, refugee empowerment, and human optimization, which was aimed to actively involve refugees in our process. Through this, we connected with Patrick Muvunga. Patrick is a refugee in the Naki Valley settlement for 14 years and is a self-taught architect. Patrick's invaluable insights and experiences have significantly informed and shaped our design approach. And so this is a part of an interview that we had with Patrick. When refugees are granted the refugee status, they receive just 4 tree branches, a plastic sheet, and a small plot of land, often in remote areas. Most arrive with no training or tools, making it incredibly challenging to build shelters. Some families, often led by women, even take 6 months to construct something very basic like a shelter. Families of 10, sometimes even 20, often live in a cramped 2 by 2-meter space without doors, windows, or security, leaving their belongings vulnerable. Furniture, even mattress, is a luxury. Most sleep on the floor. Patrick emphasized that designers often create solutions without consulting the refugees themselves. This leads to impractical outcomes that fail to meet the real needs. He reminded us that basic safe shelters tailored to the community's input are already a meaningful solution. Yeah.
Yeah, so simply saying the migrant path can be divided into two statements, from conflict points to refugee camps, from camps to the surrounding settlements with certain supplies. So our unit is for the second part, serving as a supply package.
So these are some of the precedents that we look into, like the IKEA shelter which is able to flat pack itself and is a durable solution. Shigeru Ban tents made out of cardboard tubes, which are super economical. Foster's unit, which is a durable portable solution, and Callert's duffel dome bags, which provides the basic toolkits for building earth houses in a duffel bag.
Following by all of our research and references, so we decide these kinds of design key points. First is we want our unit to have minimum assemble time, but it could be deployable manually, respond rapidly to the emergencies. And also we want our unit to be minimum volume and weight, help people easy to carry and move. Also, we will consider the economy of means, the floor elevation to help people escape from the extreme weather like the flooding, like the rain, and also we'll consider some energy and resources. So we split our design into 3 parts. And first part is the floor. So it is a design standard. Every person will have 3.5 square meter according to the UNHCR, and every family will have 5 members, even more. And our unit will supply as sleep, eat, social activity, and storage. So the floor design logic is we hope our floor could be compressed in plan, also in volume. First, we need to decide our plan. So we try to find a balance between the private space and the public space. And we also consider if we could extra support to help the floor could be elevation. We tried the scissors structure, and we use our own plan to create a scissor structure. If you rotate the center tripod, it could be compressed. We also tried different kinds of structure, and we find that the final one could be compressed very small. It's some animation about this frame. And when it transformed, the final unit could be compressed into a triangle box with the width of 2 meters and the height of 0.0 meter. However, these kinds of structure is a little bit difficult for them to deployable, especially for those who don't have the very professional knowledge about the construction. So we tried the second way. We learn from the thick panel folding system. First, we divide, its logic is divide the center geometry, rotate and copy it. So following this logic, we create our own plan like this. And we tried different growth logic. We found the last one could expand the area most. And we also explore different folding way. The first way is from outside to inside. Because of the frame thickness, it will create lots of gaps and it will influence the integrity. The second way, we fold it from inside to outside. It will create less gap, and it could allow the other frame connect to the floor. So it's our final size of this system. The final shape will be a hexagon box with a width of 1.8 and 1.1 meter and the height only 0.3. We're also looking forward to actuate our floor system. We use compliant joint and the pneumatics. So we choose pneumatics as our actuation way. It could help us actuate the floor in a very introduction way. Also, it could collect water and it could reduce the temperature if the weather is really hot. Then we consider how to realize our floor system. Considering the efficiency and strength-led weight, we reduce the material step by step from board to joint to sticks with pneumatics. We also learned from the honeycomb system. We found that the rhombus will have very high efficiency to reduce the material, but at the same time could support people stand on the floor. And we also explore some different kinds of joint to help the floor have the elevation. This is the photo of a physical model how our floor developed. And its animation, how it will open.
Yeah, the move to the roof system, we do research about several types of tent. We compare their stability, their assemble time, and package size, which we think are quite important if we want to build a long-term and affordable unit. And the result of the comparison was that we need to analyze the working principles of a pop-up tent, at the same time using the features of our tent to increase the stability of the structure. We found that there are two ways of folding. One is folding directly along the long axis of the circle, or twist it into a figure 8 before folding it. But the end result is all compressed into a plan with a very small area for packing. At the same time, we realized that the material of the pop-up tent also provides the basis for its transformation. The fiberglass pores and the polyester fabric make it lightweight, stable, and at the same time flexibility. So we began to build our own unit. We have a larger height for the private space frame than UNHCR standard, with 2.4 meter in the center and 1.95 for the side wall. And at the same time, in order to strengthen the structural stability, we add extra support between the three branch frames, while these three surfaces also provide space for the location of the windows and doors. When we tested the physical modules using piano wires, it works. It's stable enough and has the flexibility to transfer. So when evaluating the roof, it will change the height for different usage. Here's the different stage of our frame and the status of the unit. So for example, with a height of 2.4 meters, our internal space are completely spacious. That provides the refugees enough space for daytime using. And with the center 1.2 meter, the space is blocked off into multiple private space. And when the center go much lower, it will be easy to collect water and be more stable. And refugees can simply change the height using a rope with different nodes. And if we want to package, one way is to flatten the whole roof to make it fit snugly into the floor system. And another way is deforming individual branch independently, twist it, and then flat it on the floor system, and then it can transform, just follow the floor change and package. And this is what it looks like.
Okay, yeah. So as a part of the pop-up, we were also looking into pre-tensioning methods. We tested a few 4D printing methodologies digitally and also physically. However, they worked out at a smaller scale. But when we tried testing it out on a larger scale, there were constraints, not just with the scalability, but also economically, which is also one of our priority. And sorry. Next, this is the current plastic sheeting that is given by the UNHCR and the technical specifications of it. So to address the urgent need of rapid deployable shelters in refugee camps, we have chosen a very basic fabric-based design that can be incrementally developed according to the evolving needs of displaced population. This design prioritizes functionality, adaptability, and cost effectiveness while ensuring the shelter can be deployable during emergencies. The main material characteristics are lightweight, economical, and with the pop-up deployability. So as a unit, we tested out the areas that receive the most amount of heat because considering the local context, Sudan is a pretty hot place. So we then looked into the materiality of the envelopes, and as I previously mentioned, we were looking into the basic fabrics. But then how do we implement and interplay between these fabrics? We used recycled TPU fabrics, which is a great material considering its elasticity. However, it's not breathable, but it has certain translucency and is also extremely durable. Then for the insulation, the cheapest material we found was the space foil blankets, which are a great material if you want to use it for blocking the direct sunlight. Then we use a typical nylon ripstop material, which is a great waterproofing material and a semi-breathable. And to address the issue of breathability and ventilation as well as light, we introduced a fine woven mesh that is mosquito nest, which will also provide protection from the issues like the insects and mosquitoes entering the tents. So this is one of the so what we try to do was we try to package this fabrics and into layers that like the recycled TPU sandwiched between the mylar, that is the space foil blanket. And then we also at the part we tested using the same kind of material on the sides, and in the center to have certain light and ventilation, we used mosquito nets with a zip door in between and translucency at the sides. And also we introduced because this mosquito net is a pretty it's not a waterproof material, we layered it further using a canopy. Although this entire system is making sure that it keeps it very affordable and also pretty lightweight. Yeah, and these are the certain specifications of our modules. And if we consider the total cost of the fabrics, the total comes around £375, which we have considered as per the UK standards. And and the weight goes around 21.5 kgs. This is the fabrication techniques that we have considered while building the module. And the connection, like when the fabric is flattened out, the ends of the fabrics can be simply built by using velcros by the people, which does not require a lot of mechanisms and can be easily tested out. And it was also so basic fabric shelters are the basic fabric shelters are designed to be modular and scalable. So energy is an issue since people have little to no electricity. Mobile phones need charging for the torch at nights, so electricity is a major concern. Hence we looked into solar fabrics as a potential material instead of the traditional solar panels, which are heavier and also comparatively expensive. So we did certain calculations, and 2 square meter is enough for the very basic requirements of energy. And then we also looked into PCM. PCM is a substance that can store and release thermal energy by changing its physical state, typically between solid and liquid. So basically the material absorbs heat when the temperature rises and releases it when it drops. Plus they are super cheap and easy to produce at a local level, that they can be introduced into floorings and the envelope. Additional layers of components can be added over time based on the feedback from the refugees and environmental conditions. This flexibility allows the shelters to grow with the community, adapting to their specific needs while maintaining the core principles of rapid deployment and affordability. This approach ensures that shelter is not only addresses immediate needs but also provides a foundation for a long-term resilience and dignity for displaced populations. Yeah, we also looked into certain water harvesting methods like the fog net collections. Then we looked into the interior spaces.
First, we divide our plan into 4 kinds of layouts, from 3-person to 6-person. Allow the center to be shared, could enhance the circulation of the space, and allow female living together or a family living together. If the family have 5 or more members, our unit could also be connected together. It's some layouts of our unit.
Yeah. So interiors, about the interiors, the issue of the interiors is very complex because the demands are very different if you compare to different contexts and different families. So there can be families, there can be private people, but there can be people who don't even know each other. So the interior is a very complex issue in this kind of unit. But since we are designing for an emergency kind of response, and the timeline of these tents are not very predictable. However, people tend to build these over time. But certainly, when there's this emergent need, how do we address this issue of having an emergency furniture? So we were looking into Shigeru Ban's use of paper cardboards into his works, and then as we realized that our system is going to be packed in a cardboard. So how about we use cardboard as a material for the emergency response? And since it's an emergency material, it can be quickly assembled, quickly disassembled, ease of availability, cheap and lightweight. So we looked into 3 different design strategies, such as materiality, customization, and deployability. One was experimenting with cardboard beds. Since the interior space is extremely low, we introduced modular furniture by implementing these cardboard beds, which can be deployed during the daytime, providing enough space for circulation. And then we also had this idea of implementing cardboard flat sheets, which can be reconfigured into the existing packaging system, and that can be provided with zip ties, which allows people to give a creative freedom to create a emergency kind of furniture at the given place. Yeah, and this was.
So at the final, our unit could realize the floor elevation, help people not sleep directly on the ground, and we also achieve the minimum assemble time, use the pop-up tent, try to make our whole unit could be assembled easily, quickly. And also the minimum volume and weight. Is our part of kits of part, like what will contain in our unit, and what's a material, what's a structure and facilities in the box, and how our things will be transformed.
And when we calculate different numbers of units, so this is a layout of the current refugee camps. It takes the form of regular small blocks, lacking a clear road plan and public space design. Once you want to add some extra road or public space, it will occupy private space. So in order to be more equal and balanced, we use circular layout and give some distance limitations to meet the standards. And 3 or 4 living units share one sanitary unit. We use this logic to set the sanitation. And it will be okay if the units want to be connected with each other. We give the connection kits. And is how it's connect with each other. Okay. So for different shapes of segment, what we need to do is we only need to calculate how many circles it needs to cover the whole area, so we can estimate the numbers of units. And this is our final videos for the animation. Yeah.
Also, we tested out the physical prototype, and as we tested it out, we realized that it took only 10 minutes at 5 minutes at this 1:10 scale to build this from a basic folded mechanism to a complete tent. Yeah.
Yep. Yes, and it's our video to show our work in this our happy jewelry. Yeah, and I will introduce our models. So these models are how we explore our floor system. It's how the plan develop, and it's a thick panel folding system. If you play with it, you could find the area could be spread or compressed. This is our section model for the transformation of top structure, create different height and create different space. And this is a transformation, like the frame, how our unit look like. And this is our floor system, how it developed. We reduce the material, add a honeycomb. And this one, we are talking about the storyline. Like the refugees, they will escape from the conflict point and they will go to the UNHCR basement. And at last, they will go to the settlement provided by the government. And this one is the current situation, the very great layout, but we will create a better unit for them. And this one is we use the piano wire to simulate our transformation, like how our things could be packed, how our things could be built. We use Velcro to make this, and you could see how it could be built. And we also could twist all the piano wires to pack it. This is how our unit could be connected. So it's this shape to help different units to connect 2 with 2, 2 with 3. And this is the section model to show our fabric. It have different layers of fabric, also the inside, the layout of the furniture. And this part is our layout of the plan. It have allow 3 to 6 people to live, and also these are some piano wire models to test the bistable thing and how it could be split into different parts. These are very initial prototypes. We try pneumatics. We change the area of the airbag to see what's elements to influence the pneumatics. These two are some 4D print tests. We use geometry as our change thing, and we found that this shape, the square shape could be compressed very efficiently. And this is our fabric panel to show what kinds of fabric we use. And this one is the scissors structure, and it's the test of different structure, how it could spread, compressed. And these two models is to show how our floor could be actuated. This is the compliant joint. If you twist it like this, and if you lose your hands, it could be pop up. And these are very initial models to learn about the compliant joint. We tried different geometries from triangle, square, and hexagon. Also add some surface to see how it could be transformed. Create different layers like this. And this cardboard is the furniture, our inspiration from the cardboard, how our bed could become very big to become a bed, and when people don't sleep, they could compress it, use as a chair or table. Thank you.
well, I am fascinated by the work. So wonderful, wonderful, wonderful. Super nice to see all the developments, and yeah, and also to see how thorough you are with the tectonics, with the material, with the performance. So fantastic. My only comments, if I may, would be more like, I think there is a relationship between cost, performance, and material use that is constantly changing throughout your project as you go and develop it. And what remains unchanged is the context where you plan to apply it. And it seems to me that there is a moment, almost like an invisible line, that if you did a graph, there is an invisible line that says this is viable and this is not. And there are some of the solutions where it feels to me that you have passed the line and you didn't realize it, because maybe the relationship between those factors would need to be more clarified and stronger. So what I mean with this is that doesn't mean that the unit is not viable, but maybe the context must change. So what you have here is an amazing array of possibilities that would be true for many different contexts. And some of those material choices might even change, and some of those structural changes might even be necessary because of the context. So I can see a glamping in the Netherlands, as much as a refugee camp in Sudan. But those choices would be different. And it would be very, very, very nice when you would have fundamentally understood what is the relationship between them. That's all I can say.
Thank you.
I also want to say congratulations to the project. I mean, it's a very important topic, and certainly aesthetically very beautiful. Whereas in this opportunity I felt is like, I like the folding analysis, and when it becomes just a phrase, I thought there's a missed opportunity because they're always the same size. So there could be opportunities where you fold it less, it's taller, and it's for one person, and then you fold it more down, then it becomes bigger, and it's for 3 people. So when it's just becoming a flat base, then it's always the same size, and you can only extend them by connecting the units. So to separate the top to the bottom, I thought there's maybe a missed opportunity where the folding could be more part of the whole pavilion, and then the size is depending on how much you fold it. So I don't see them really, but I like these models, the black ones, because they have different sizes, and I could see there's a adaptivity on the scale, and also, I mean, these are beautiful studies, all of them. I just feel like I was hoping that the top and the base maybe is more of one system. That would be my comments, but a great project. Thank you very much.
Thank you.
Yes, very interesting, very important question, and quite in need of attention. So I really appreciate you taking your opportunity for research into this area and doing some background sort of research to see what are the precedents, etc., what are the places in need. Now, the thing that I find quite from the limited experience I have of what they do end up with is that a lot of these camps, in what I understand, end up being much longer term than what normally is planned for. And they become almost like little villages, etc., that go beyond their planned time. So this idea of how these quick things or cheap things become like nuclei of a longer term development is a very important thing. So in some way, the economy of the original object kind of should be counterbalanced in its sort of potential endurance. Now, that means that these tents that might originally be just a quick kind of response, in my view, can be thought of as pieces of a village that actually involve life in a longer term. So, for example, how these people cook, what kind of infrastructure you produce for their toilets or for kitchens, etc., become just as important as the original shelter. So shelter becomes like something of a little, I don't want to call it town, but definitely a village in potential. And even in a kind of short term, they need that kind of infrastructural assumption and potential sociality between them, because these are traumatized people and they need to have huddled together, and this idea of how they interact and socialize become just as important as the sort of weather shelter, etc. So I am very impressed by the actual material and structural studies that you have done, which are quite inventive, very lovely beginnings, actually. I would like to suggest that it would be important to actually get involved with these kind of intermediary spaces, which are half open or in the flooded condition. They are safe, but they are outdoor, they breathe, and they are spaces for intermixing, socialization between them. So this brings a whole different, I know that you have these mediating kind of fabric, but because they are always kind of curved, they don't necessarily suggest use of the ground. So a certain kind of a deck of some kind, which is connected to probably disposing water or having a toilet or not smelly, etc. Some other kind of intermediary infrastructures become just as important as the shelter original thing. And I wonder if you could think about that in your future expansion of the work. I hope you do actually follow it up. It's a very important thing. Thank you.
Thank you.
Very cheerful little project. Great student work, reminds me of 50 years ago here. Wonderfully optimistic, technologically optimistic, and I think as far as you've got is great. The challenges are, as you increase the scale to full size, the materials change, the properties of materials change, elasticity changes, weight changes. So as you grow towards a prototype, what you now need, of course, is a bigger prototype. It will change. But I think I congratulate you on the inventiveness with which you've tackled pretty much every aspect of your invention. You've found a way to do it, and certainly demonstrated at the scale that we have here. There are other examples at much larger scale which do work with the sort of ingenuity of these systems. So I think it's full of ingenuities and full of ideas. And I think the next element would be testing it at larger scale. I think that's the most important thing. The feedback from the next scale up will be fundamental to whether it works or not. There are lots of worries. How do you tie it down in strong winds? Classic problem in these camps. A sort of table system for the foundations looks a little bit optimistic. One has no idea what the ground conditions will be. If it's boggy ground, you have a completely different problem. If it's hard ground, the ground's virtually never flat anyway. So there are issues of the base. And it seems to me that the shelter notion is a fundamental step forward. The base may have problematic issues because it's an extra, because the ground that's already there provides 90% of the support that people generally start with in any camping environment. So in a funny way, I think the bottom half, the base, although ingenious, may be the luxury, whereas the top is ingenious and maybe essential. But great work. Cheerful so far.
I think it's very serious and very well researched. I like that part a lot. And you're competing economically. You want to be, you have an economic kind of tracking, which I do like. Weight tracking, speed of construction, speed of and ease of unfolding, etc. So all of that, I congratulate you. And the final videos look beautiful. I have one major challenge. You spent maybe too much time on that floor. I mean, that's maybe, yes, it works. It seems it unfolds, and then the model is very impressive here, that it all unfolds into one box and all connected. But I have a problem with the model, and I wonder whether you've solved it, which is the images look very taut, and the beautiful ingenious little tent which pops up because you thread these fiberglass rods into fabric, and it generates this beautiful form that you could have, and here's a bit of this, but this is too floppy, too thin, and the fabric at this point has to be either tailored or be elastic. So on that level, I think this is my criticism. I'm sure you could do it, and it's in there. It will mean these forms would be anti-classic. So these fabrics need to be either elastic or tailored, and you should work on this, because the crumbliness of this, is obviously not what it should be. And then you render it so slick and beautiful, so light. That's lovely. But if you look closely, there should be more anti-classic, these surfaces. So because you also here you use sheets and solids, so that would be my criticism. In the next model, like, we absolutely, as you scale up, but you should also on that scale maybe do the model which is more this pops up into precise shape. So you need to calibrate them, probably using stocking or some elastic fabric and some stronger of these members, and the way they generate the force of the elastic captured in the elastic pushes out this tent. So that would be my comment. But overall, I think it's a very, very sophisticated project and serious project, credible project.
Yeah, it's great work. And I really like that you engaged with the refugees. But when you go to the next step and talk to the UN, there's actually a logic why these camps are so poorly designed. And they actually have no interest in changing that, because in their mind it is temporary. And the idea that in reality they are not, but there's a big starting point. I think conceptually, I think it would make sense to start with that, to say, the reason why it's in such a poor state at the moment, the design or the whole layout, everything is a catastrophe. But at the moment it's deliberate, and so I feel like there's a missed opportunity just to make a strong point that we know now, looking back, you can prove that, these camps have been established and they were intended to be there for a short period of time, but now some of them have been there for 20 years, 30 years, and they are really like towns, right? And that was a missed opportunity, I think. And then the other thing, I liked it where you went with the cardboard box and making something out of these materials. I think one could also look at all the other stuff that is getting brought to those camps, right? And a lot of those camps, the water supply actually is through bottles, which is a tiny bit insane, but that's what it is. And so you have the bottles as a material, and then stuff comes in sacks and whatever. But for the interior spaces, I think one could in the next chapter go further and see all the other materials that are on site anyway. What can you make out of them? But in general, I think it's a beautiful piece of work, and really great work. Thank you.
Thank you.
Well, maybe a short comment from my side. First of all, I really appreciate your project in many ways, starting from the choice of the topic, the choice of the area that actually you're decided to work on. We're talking about more than 1 million of people involved on this war and displacements and crises of all senses. I mean, in all different kinds of issues that are suffering and challenged with, including now also like extreme climate conditions. So I think, in a way, the way you approach the problem, I think, is quite valuable. It's a very complex topic, and as a tutor, I can tell you, I had the same difficulties also that you had in terms of addressing all kinds of technicalities, all kinds of issues that are related to the occupation that could be, as the comments, could be temporary, can be permanent. Can be both, actually, because wars are not really taking care of borders. They're not taking care of specific locations, and there is a kind of ever-changing kind of condition. So there is also this aspect about migrations, continuous movement and displacement. But I think the way you approached it is also valuable, in my opinion, is because technology should be coming to help and support also these extreme conditions. With the limits, of course, of the economical and logistics, economical issues and the logistics of it. But I think it's good to really use our kind of architectural thinking to somehow challenge ourselves and be more and more involved on these topics that are, most of the time left to a very bare and crude engineering, very, kind of basic approach towards, whoever is gonna live in these places. And so I think it's important to work on these aspects. And I agree, it's a piece of research. There are many issues about prototyping, like a one-to-one scale object. But at the same time, I think you addressed some of the issues with some interesting degree of intelligence. Even thinking about the floor is not something secondary. Above all, like if you think about all the issues coming from hygiene and climate, kind of extremes that they need to deal with. So in general, I congratulate you, and I have to say personally, this is one interesting trajectory that we should all try to embrace as designers.